This is a video for OCR Pure Core Mathematics, Calculus 3, Integration Using Partial Fractions, 3.1, Partial Fractions Recap. So a quick recap. If we look at this algebraic fraction here, it's got two factors in the denominator, and we can split it into the sum of two individual fractions using each of those factors, x plus 1 and x minus 4. Let's think about this example. I'm going to write that this is identical to, and I'll come back to that in a second, a over x plus 1 plus b over x minus 4. It's identical because for every value of x, these two things need to be exactly the same value. So multiplying through by this common denominator, I'm going to get that x minus 9 must be a lots of x minus 4 plus b lots of x plus 1. Now again, this is an identity, so every value of x must work. In particular, a value of x equals 4 must work, and that will have the effect of zeroing out this first part of the expression. So if I look at what happens when x equals 4, my left-hand side is just minus 5, and my right-hand side is 0 from this bit and 5b from here. So this means I must have that b is equal to minus 1. And again, because it must work for every value, if I choose a value of minus 1 to zero out this bracket, so think about what happens when x equals minus 1, I get minus 10 is equal to minus 5a, and we already know the other bit must go. So this implies that a is equal to 2. And so now I can write that my original fraction, x minus 9 over x plus 1 x minus 4, is equal to 2 over x plus 1 minus 1 over x minus 4. There's that working written out neatly so that you can follow it. Here we've used the identity with two values, x equals 4, giving me the value of b as minus 1, and with x equals minus 1, giving me the value of a as 2, and there's my final result. Okay, so what about repeated factors on the bottom? Well, the technique is again to split it x minus 1. And the problem is, what do I use here? Well, I could have some x plus 3's, and I will have some x plus 3 squareds. So with the repeated factor, the trick is to use a fraction for each of the powers of the repeated factor. So I've got a fraction here with just x plus 3 to the 1, and a fraction here with x plus 3 to the 2. If that had in fact been cubed on the bottom here, I'd have 1 for x plus 3 to the 1, 1 for x plus 3 to the 2, and another 1 for x plus 3 to the 3. Again, multiply through by your common denominator. Still an identity. This is going to gain x plus 3 squared. This is going to gain one of each, so an x minus 1 and an x plus 3, and this is just going to gain an x minus 1. So now I want to think about values of x that I could use in this identity to see if I can get the value for the constants. Well, this bit here suggests that I could use a value of x equals minus 3, so let's have a look at that. X equals minus 3. I'm going to get 12 from the left-hand side. That will go. This one will also go because that's got an x plus 3 in it. And this will be minus 4c. And that's going to give me that c is equal to minus 3. Going back and looking at my brackets, it looks like x equals 1. We'll get rid of those. So let's plug in x equals 1. I'm going to get 16 here. I'm going to get 16a, nothing from here and nothing from here. So that's going to give me that a equals 1. So how do I find the value of b? Well, technique here is to look at a coefficient. So let's have a look at what happens to the x squared terms. On the left-hand side, I haven't got any x squareds at all. And on the right-hand side, well, this will give me an x squared term, so there'll be an a. And this will give me an x squared term, so there'll be a b. This won't give me an x squared term. So I've also got that a plus b equals 0. We know that a equals 1, and so that's going to imply that b is minus 1. So my partial fractions for x plus 15 over x minus 1, x plus 3 all squared is going to be a, which is 1, over x minus 1, plus b, so that's going to be minus 1 over x plus 3, plus c, which is going to be minus 3 over x plus 3 all squared. Again, there's that working tidied up. You can see we've used a value of x equals 1 to find a value for a. We've used a minus 3 to find the value for c. And we've looked at the x squared terms, knowing already that a equals 1. That gives us the value for b at minus 1. And so there is my final result. So the summary template for this is, if you've got a single linear factor, you get a single fraction in the result. If you've got a repeated factor, you need to consider a fraction that uses each of the powers for the repeated factor. So the summary method then, we split the fraction into a sum of fractions, and you have one for each factor in the original. If you've got a repeated factor, then you get a fraction for each possible power of that repetition. Multiply through the denominator, and then use selective values of x to zero out each factor in turn. And that allows you to find the constants in your sum. And if you've still got things left at the end, if necessary, you look at the coefficients. And if necessary, for each power of x, to find any remaining constants. The next video in this sequence is 3.2, partial fractions with a denominator that has a quadratic factor.